All right, guys, this lesson is on how to read chemical formulas, which is basically just identifying what elements make up a formula and how many atoms of each element. So let's get started. Okay, so take this formula, magnesium oxide. Now, this formula, MgO, I know that there are two elements that make up this formula, Mg being magnesium and O being oxygen. The number listed next to each element kind of tells you how many atoms of each there are. So magnesium, as you can see, has no number written next to it. Whenever there's no number, we read it as an imaginary 1. Now, these little numbers are called subscripts. So that guy right there, he's called a subscript. And that tells you how many atoms of one element you have. So for both of these, that means there's one magnesium atom and one oxygen atom. And that is how we write it. If I were to write this out, I would say 1 atom of magnesium and 1 atom of oxygen. And that is this simple formula. We're going to move on to the next formula and see how they get a little bit different when the subscripts are a little higher than 1. Okay, so in this formula that's seen, you see magnesium has a little 2 next to it, and the O has a little 2 next to it, the oxygen. So what this tells you now is that there are 2 atoms of magnesium and 2 atoms of oxygen. And that's how you read this formula. This, again, is a chemical formula that tells you what elements and how many of each element make it up. So this right here is a formula you'll see sometimes, and I wanted you guys to see this. It says 4H2O. So already you know that you have H2O, which is water. Again, already recognizing the little 2 is the subscript. It means there's 2 atoms of hydrogen and 1 atom of oxygen. No number means it's 1. But what do you call this guy right here, this big 4? That big 4 right there is called a coefficient. Coefficient. I can't spell. That's okay. Coefficient. Now, with the coefficient, this is what it means, and I'm going to draw it for you guys off to the side. This and this mean the same thing. I don't like to write H2O 4 times. They're equivalent. So I could write H2O 4 times, H2O, 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 because technically speaking, H2O is 1 molecule. And that's what I'm trying to show you guys right here, that box. That is H2O. H2O is one thing. And then if I have a big number next to it, that's called a coefficient. It means I have 4 molecules of H2O. Those two are the same. I want to show you how to count this, so let me reset it up real quick for you. So if I had to count the number of atoms in this formula, it's a little bit different. So let's see how it's different. It's a little bit of math, just a little bit of multiplication. So you can do it one of 2 ways. You can do it like this, where it's H2O 4 times, and that gets a little tedious when these coefficients get very big, like 12 or something. So now if you were to add all these up, I know that I have a total H's. How many total hydrogen atoms do I have? So I would just count. And you can do the math in your head, or you can do it on paper. So 2, 4, 6, 8. I have 8 hydrogen atoms. Okay? But I'm not done, because now I have to do oxygen. And because oxygen has no numbers next to it, that means there's just a 1. So when I go to write this guy, I just count 1, 2, 3, 4. So now I know I have 4 atoms of oxygen. So if I had to put a total, I know I have a total of 12 atoms in this formula. Now that's one way to do it. I'd like to show you another way. Okay, so here's the other way to do it. It's a little bit of multiplication. So I take this big coefficient and I multiply it times each of the subscripts. And I'm going to do that quickly, and I'm going to show you my answers. I'll show you the answers in, let's do blue. So 4 times 2 gives me 8. That's how I come up with 8 atoms of hydrogen. I took this big 4 and I multiplied it times the little 2 next to the H. Remember, the subscript always belongs to the guy on his left. All right, so that's 8 atoms of hydrogen. Now I'm going to do the exact same thing. 4 times this 1 oxygen. So 4 times 1 is 4. So again, it's the exact same math as before, and you can see it. I've got 8 atoms of hydrogen, and I've got 4 atoms of oxygen. That is how you use a chemical formula with a coefficient to count atoms. I'm going to keep going because they get a little harder. So what happens if you get a formula that looks like this, where there is 2 of the elements in parentheses? Well, what that means is when they're in parentheses means they're together, they're bonded, but they're 2 separate elements. It's oxygen and hydrogen, and you can see it's got a little 2 for a subscript. So how I would do this little 2 only belongs to the guys in the parentheses. So there's 2 applies to the oxygen and 2 applies to the hydrogen. So if I had to ask you guys how many atoms of each, you guys know that there are 1 atom of magnesium. Oxygen, there's 2 atoms of oxygen, and hydrogen also has 2 atoms. So total number of atoms in this formula is 5 atoms. Again, this little 2 does not go and apply to the magnesium. It only applies to the one off to the left, which is the one in parentheses. Anytime you get a parentheses and there's a subscript, the little subscript only applies to those within the parentheses. So what if you get this beast where it's a parentheses, it's got subscript, it's also got a big coefficient up front? Well, this one, you just got to break it down. Do it in sections. Always start with the one in parentheses. I want to remind you guys that this little 2, he applies to the oxygen and to the hydrogen. So underneath, I might put oxygen equals 2 atoms. Okay, and hydrogen also is 2 atoms. But wait, there's more. This big coefficient right here, he also has to be applied. So I have to now apply this coefficient, remembering that the coefficient applies to everything in the formula. So this coefficient applies to this guy, he applies to the oxygen, and he applies to the hydrogen. So now what I need to do is, let me erase some of those arrows so you guys can see it a little bit easier. I'm going to start applying them, and I'm going to write my totals over here. So this 2 times 1 magnesium, because remember, no coefficient means there's a little 1 right there. So I know I have 2 atoms. Magnesium, there's 2 atoms. So that's the easy one. And then I need to apply this 2 to how many oxygens there are. But because we did this math, we already know. So I know that I take 2 times 2, and that gives me 4 atoms of oxygen. Again, I will show you how I got that. I took the big coefficient, and I multiplied it times the number of oxygen atoms I had. I already found out the number of oxygen atoms using the little subscript, and I applied those in the parentheses. So that makes 2 times 2 is 4 atoms. I'm going to do the exact same thing for hydrogen. I'm going to take the big coefficient and multiply it times the number of atoms of hydrogen. I'm sorry, I forgot to write the number of atoms of oxygen earlier. There's 2 of those. Okay, so let's do it. 2 times 2 of those. So for when I come to hydrogen, I know I have 4 atoms of hydrogen. Okay, hopefully you guys are getting this. Okay, let's wrap it up. So this is one that has a coefficient. It has a subscript. It was like the one I showed you with water. But again, this is from the notes page. A lot of these examples I'm using come directly from your notes. So in this example, I have to remind you that this coefficient right here, he applies to every single atom, or I should say element, in this formula. So I know that I have 3 times 2 magnesiums. So that means the total number of magnesium atoms I have is 6 atoms of magnesium. 3 times 2 is 6. And the next thing is I'm going to take the 3 times the 2 atoms of oxygen. That means the total number of oxygen atoms I have is 6 as well. If I ask somebody how many total atoms in this formula, I expect you guys to be able to just simply figure those two numbers out and then just add it together. 6 plus 6 is 12 total atoms. All right, I might do one more example. So this is the one you've already seen before as well. I changed the coefficient just to kind of, again, challenge your brain. See if you can work it out on your own before I show you the answer, and let's see if you can get it right. So pause the video and see if you can figure out how many atoms of magnesium, how many atoms of oxygen, how many atoms of hydrogen, and how many total atoms. Okay, so you just got done doing your own work, so let's see if you were right. The first thing I'm going to do is apply the subscript to the one in the parentheses. So I know that down here I have a total of 2 atoms of oxygen, and I have a total of 2 atoms of hydrogen. Okay, that I did the parentheses first for a reason, because I wanted to do the little subscript. Now I can do the big coefficient. So when I do the big coefficient, I know that this guy applies to the magnesium. So there's no number there. That means it's an imaginary 1, and 3 times an imaginary 1. So I know I have a total of 3 atoms of magnesium. Okay, now I'm going to do the next one. 3 times the number of oxygens. We already worked that out down here. There's 2 oxygens, so 3 times 2 gives me 6 atoms of oxygen. The next step is to do the hydrogen. 3, this big coefficient, applies to the hydrogen, but we already worked that out too, right here. So 3 times 2 hydrogens, so that gives me a total of 6 atoms of hydrogen. Now that's if I were to ask you how many of a certain element, how many atoms there are. So anybody on any test question should be able to tell me, oh, there's 3 atoms of magnesium, there's 6 atoms of oxygen, there's 6 atoms of hydrogen. Now let's do a total number of atoms. So all you do is just simply add them up. 6 plus 6 is 12, plus 3 is 15 total atoms. And I'm going to write that, atoms total. So you know, in any given formula, you should be able to tell me how many atoms of each element and how many atoms total there are. And that's going to become important when we start looking at chemical reaction. Hope you guys got something from this. Please rewind, rewatch it as many times as you can. I teach these periodically. Haha.